Hey everyone, today we're going to be talking about vertex forming the axis of symmetry, except without the intuition, because the videos I'm getting a little long and I suck at explaining intuition, so we're just going to be looking at just vertex form, how to do it. So what is vertex form? More specifically, what is the vertex? In terms of a parabola, you can sort of think back to geometry. It's like where two lines meet. In this case, it's sort of like, I guess the halfway point. It's like we draw the parabola out here. We have something like this. This point here, we do that in a different color. This point here would be our vertex. It is the absolute minimum point of our parabola. It does not get any lower than this. In fact, right after this, it goes back up. And before this, it's sloping down into our minimum point or our vertex. Other parabolas, if we have a negative coefficient or negative a as our coefficient, it'll look like that parabola but upside down. So in that case, our vertex is no longer a minimum point, it's a maximum point, or the highest point of our parabola. So everything before that goes up, hits that point, everything after that goes down. So that's sort of what we're trying to find here, and instead of using calculus to do so, even though you could do that, we're going to be converting it into vertex form, converting quadratics into vertex form, that is, which looks like this. Generalized, it looks like a times x minus h, usually squared, and then plus k. So how do we get this to look like that? Well, as I explained in like 2 videos ago, we're going to complete the square. So what completing the square entails is we take b, in this case is negative 5, divided by 2, so negative 5 over 2, and square it, which is positive 25 over 4, and we're just going to add it to just the right side of the equation. But when we do that, we also have to subtract it from the right side of the equation as to not change the value. So what that looks like, after we do that, we get x squared minus 5x, and now, ooh, that's a bad x. There you go. And then we're going to add 25 over 4, because that's b over 2. Like I said, negative 5 over 2 squared, 25 over 4. And then we're going to add 6, but now we're going to subtract 25 over 4 as to not change the value of our equation. Okay, now what does this do? Now you don't want to cancel these terms out because you'll just be back at square one, but as implied by the name, completing the square, this makes, at the very least, this portion for a quadratic a perfect square. So now we can factor it out properly. We get x minus 5 over 2 squared. And then this here, 6 as a fraction would be 24 over 4. So minus 25 over 4, we just get minus 1 over 4. Now, if you had a coefficient, if a was not just 1, it would be hanging out here, but in this case, a is 1, so we don't have to worry about it. But now we have successfully completed, or, well, converted our quadratic into vertex form. Now, what do? Well, let's think of this quadratic. As I drew out earlier on our graph, the coefficient here is just 1. It's not negative, so we know that it'll be an upwards opening parabola, meaning it'll have a minimum point, not a maximum point. Now, what we essentially want to do here is find where that minimum point takes place, or at the very least, our x value. And so thinking about the intuition, we know that x minus 5 over 2 for all real numbers is just going to be positive. And since it's always positive, in order to actually reach a minimum point, we need to make sure that this essentially adds nothing or equals 0. So all we do is we set the inside of this to equal 0. So x minus 5 over 2 equals 0. Therefore, x would just equal 5 over 2. What that means is for the x value for where our vertex or minimum point takes place would be 5 over 2. So over here, that's just 5 over 2. Now, this would be great if we were just looking for the axis of symmetry, because I guess I should explain this, but axis of symmetry is literally just the line, like just a straight vertical line that you could reflect your parabola on and have it be symmetrical. So since it's just a line, we can say it's just x equals 5 over 2, right? The slope is undefined, it spans all sorts of y values, so all we need is the x value. So we have just found our axis of symmetry, but we have not found the full thing of our vertex. We still need to find the y value that it takes place on. And, well, in this case, when we have it converted to vertex form, that's easy. We already did that. It's just, well, setting x equals to 0, x minus 5 over 2 equals 0 gets us x equals 5 over 2. But since this becomes 0, we can just cancel that out, and we're left with minus 1 over 4. So this point right here would be minus 1 over 4. So what that tells us is our minimum point here takes place at the point 5 over 2 minus 1 over 4. That's our ordered pair there. Now that's great. You know, we found vertex form. We solved for our vertex and axis of symmetry. But now, let me erase all this. I'm going to show you a different method to find axis of symmetry and vertex form. It is a little bit faster. I will also not be explaining the intuition behind this one because, truth be told, I don't actually know. But I do know how to do it. And this is going to initially find our axis of symmetry. We say that x is equal to negative b over 2a. And after doing that, this, gets us just the x value, which in turn returns our axis of symmetry. But after that, we can plug this x value back in to find our actual vertex point, or minimum point in this case. We get out a y value, and that's the y value of our minimum point. So let's just plug in some numbers. Negative b, in this case negative 5. So let's say x equals just be positive 5 because it's double negative over 2a. In this case, a is just 1, so it's just 2. So bam, we got our x. Our axis of symmetry takes place on the point 5 over 2. Now we just have to plug this 5 over 2 back into all the x's in this equation, and we'll get out our y value. So 5 over 2 squared is just 25 over 2, sorry, not 2, 4, minus 25 over 2. All I did was just plug in the x value here, minus 25 over 2, and then plus 6. So if we want to, make this whole thing common denominator, in this case this would be 50 over 4, so we would have minus 25 over 4, and then, as I said earlier, 6 as a fraction. As a fraction with 4 as its denominator would just be 24 over 4, so we add that, and we get minus 1 over 4. So this right here is our axis. I'm not going to write out symmetry, I'm just going to say sim of sim. And this is just the y coordinate of our minimum point. So in total, we would have 5 over 2, minus 1 over 4. And just to verify that I'm not lying to everybody, let's graph that out. Ooh. So here, our very minimum point here, minus 2.5, or sorry, 0.25, which, 1 over 4 is 0.25, so we got that right. And this is also 2.5 here. 5 over 2 as a decimal is 2.5, so we got those two values right. And if I just do x equals 2.5 here, we can see that our axis of symmetry crosses through our minimum point here and cuts it straight down the middle, so that if you reflected by this line, you would just overlap the parabola. So yeah, that's just vertex form and axis of symmetry in one video. No intuition, because I wanted this to be a little quick, and I want to go to sleep. So yeah, thank you for watching.